All right, are we good? All right, so this talk is Monadic logging and you. I'm Martin Snyder. I'm from Wingspan Technology. Wingspan does document management applications for regulated industries. And what I want to talk about today is how logging practices haven't really kept up with the complexity of applications. And this has really created a mess for a lot of people. The first one is that the immediacy of logging implies synchronization in your code. And what will happen to some people is you have some transient problem, and you decide you're going to try to diagnose it by turning on max logging. You turn it on, the problem goes away. It goes away because your problem may have been caused by timing or synchronization. And when you're going through the same code paths with logging, writing to a shared log device, a file or something like that, you're going to lockstep the exact program that you're trying to take a look at. And that kind of neutralizes some of the benefits. And even if you don't have these sorts of problems, turning on logging in a situation like that will affect performance, right? You're going to synchronize code which may not have been previously synchronized. This gets into a lot of functional programming things. I mean, we're introducing, there's a side effect there, but the side effect is synchronization, which turns out to be a really terrible thing to have be conditional based on settings. So the next problem is you have some scenario the user can reproduce a problem. It's a multi-user system, though. When you go and pull the log file, everything's interleaved with all the other users of the system. And you know this one person was going down a path of failure, but you have a tough time kind of collecting all that. And you can mitigate that pretty easily. I mean, you throw a thread ID in there, a request ID, a user ID. But at the moment you're trying to log things, you may not have that information. And you can introduce those dependencies to your code, but that doesn't seem like a great idea either. So there's a couple risks of going down that path. So now in this case, you're in a stateless cluster. And again, the user knows what they're doing. They can reproduce the problem. And all you got to do is collect the log file. But now you got to collect log files from every single node in the cluster. And you got to hunt and find the one that corresponds to what you're looking at. And that's unpleasant. And you can mitigate that. The easiest way to mitigate that is with Splunk or anything like Splunk. And those tools are great. And I'm not saying don't use those tools. You probably use them in addition to anything that I'm recommending. But it's unfortunate. The answer kind of leads towards greater complexity. And I think that as functional programmers, that's something that we're trying to avoid. The fourth one is similar. You're in some multi-tier application. It might be simple. You might have 2 tiers, or you could be doing microservices. And you could chain all these things together. And something goes wrong at some point in the process. And what you really want to see is that orchestrated log of everything that happened across all these tiers. And that turns out to be inconvenient to collect. And again, Splunk will help you with that. You can also create an artificial request ID and kind of propagate that forward and stuff. But again, you're introducing things to help you with logging that you may not really need to deal with. So what we're talking about as the answer is monadic logging. And we're going to breeze through this because I think most people here are pretty familiar with basic concepts like a writer monad. This is the shortest one I could write. I was trying to fit it on the slide. It basically will just pair a value of any type with a list of string messages. And you can see how you can accumulate those messages over time, and you can kind of build a narrative of how you arrived at some value. And then we'll look at a use case of there. We don't really need to look too closely, but in the center of the main, there's a for comprehension, and that's kind of the key element of using a writer monad, is you have some way to compose these things together where you have a path of execution, and it's accumulating the log messages. And if you look at the very bottom, we'll see that we have the outputted, the formatted string, and it kind of carried those log statements that it got from the top methods, and it can output them all together at once. And then a logging monad is the same thing. I mean, a writer monad, I think, is classically exactly a list of strings. I'm just suggesting some case class that has more log information. So it's whatever really you want. In this case, we have a timestamp and a string. You can imagine a log level. You can do a lapse timing of how long something takes to execute. There's really anything you would want to throw in there, you would throw in there. But the composition is exactly the same. So now we're in great shape. We've solved all the problems. The first thing that we've done is that because the log entries are being accumulated as you execute and then passed back up to the original call site, there is no immediacy, right? The log is accumulated as you execute, but it's not written to any log device until you mechanically choose to do so. So there is no notion of synchronization. Logging doesn't really have an impact on the performance of your application from a synchronization perspective. The other thing is that when you do have a log file itself, you're going to have fewer total writes. The writes will be larger. You're going to be sending the same information there, but you'll have fewer writes. You have fewer contention on the resource. The interleaved log entries, again, this is knocked right out of the park. No longer do we write log entries as they are, appear in the code. Now you've executed the full request. You're back at the original call site. You're getting ready to terminate or send the response or do whatever it is you're going to do. And so there, you have all the context information. You can emit one time. In this case, we have an IP address. We have a user ID. We have the URL of a request. Whatever it is that you consider to be the context, that appears at the top of a banner, followed by all the log entries. Everything is in one atomic unit. The context is there, but the log statements themselves have no awareness of that context. You did it all without introducing any additional dependencies. And that's what this can look like here. We have just a brief example of that banner. So again, that clustered server scenario where you have to go and hunt to find the log file, we've solved that as well. And the way that we solve that is you can take that log information, and you can do whatever you want. You can write it to a log file. You can do normal things. But in this case, we're going to put the log entries on the HTTP response itself. So we're imagining we're a RESTful service. We've gotten some requests. We've accumulated the response. And as we're about to stream the response, we'll put the headers in first. They have all those log entries. And now the caller has that information as well. You can combine that with a client log or any sort of other things. It's the same information. Now, there's different ways you can do that. You might have you can put it in your hypermedia format, but some services might have multiple formats, like you can do XML and JSON. So it can be convenient to throw it into the headers to avoid having to kind of manipulate your format. The other case, something that we do at Wingspan, is we do a lot of dynamic generation of PDFs, and there's no convenient place in the output format to put this sort of information. So putting it into the headers is very nice. Now, of course, the one note, I think probably a few people are sniffing this one out, is you'd want access controls if you did this. I mean, you wouldn't just want to be sending your server-side log to every casual user of the system. The cross-tier correlation is the same thing. If we just build off of that, the HTTP response answer in a multi-tier application, you can imagine each subsequent request is sending its log back to the intermediate service, and then they accumulate and they pay it forward. That's based on everyone participating the same way, which I think today and probably tomorrow is unlikely. So this is a little bit of a forward-thinking dream. For now, it's unlikely to happen. Just use Splunk and consider yourself lucky that we've solved 3 or 4 problems for sure. So the title of the talk is Monadic Logging in U. And it turns out to be an important distinction, because this isn't the kind of thing where I can be up here talking about an open source library that I've published in Maven that I want you all to include and use instead of Log4j or something. That's not the way this works, because logging is a lot more about the practical use of logging than about the library that you use. I mean, you can usually switch log implementations pretty simply for that reason. So the real thing, less so than using these mechanics or doing anything in one particular way, is changing the mindset of logging to kind of be more compatible with what we're doing as functional programmers. Okay, so the first message for everyone is to log less. Okay, the purpose of logging is to provide insight into running code. That's the most important perspective to maintain here. And if you're doing functional programming correctly, there's a lot of cases where you just don't need it, right? I mean, that's what we're trying to achieve. You have the inputs and the outputs, and there's no side effects, and it's provably correct. You have trouble unit testing sometimes because it's so obvious that it works correctly, and there's no need for logging in those cases. But that begs the question, well, where do you need logging? And there's 2 really good targets. I mean, the first is any I/O boundary, anything involving a network call, a database call, or something like that. And you'll probably already have these marked in your code, because they're going to have a try or some result type that recognizes the fact that, hey, I don't know exactly what's going to happen here as I'm writing the code. I'm going to find out later. That's exactly where you would want logging. The other thing is that sometimes you want to time stuff. Like, you don't really see when you're writing code how long it will take. And I know we want it to go, as fast as it can go, except in cases where you don't. And the best example of this is you're trying to compute a password hash. And it's actually important how long it takes. You don't want it to be 0 milliseconds. You also don't want it to be, a minute and a half. You want it to be like 1 to 200 milliseconds. You want to tune that over time. So there's some times where even if you do have functional code, you would still want to log it. I consider those to be pretty rare. So the next thing is you're going to want to combine your result type with your logging monad. The reason you're going to do that is just because Scala is not great at handling nested monads. And you can use something like a monad transformer, and there's other techniques as well. But if you do use this thing, you're going to use it a lot. And it's not a lot of code to handwrite. You're better off just having some straight line implementation that does exactly what you want to do. The result type doesn't make a difference. And it turns out this is very easy to write, because the writer monad interface is quite simple. The result type interface will typically be quite simple. And they're completely compatible, because the writer is doing accumulation, and the result is typically doing a conditional execution in a flat map or something like that. So they really don't collide very much. You can just union them together and go and start using it. So one thing that comes up a lot is when people are doing traditional logging, they have like a debug statement that will build some expensive string, and so they want to do deferred string construction. They're always thinking, well, how do I avoid doing this work in the case that this entry isn't needed? You can run into a lot of problems here. Okay, this is something where if you carry this practice forward and you're doing functional logging using monads, what's changing is that the line of code that executes the log statement and the materialization of that log entry are the same, basically. That's the immediacy thing. And now that we're no longer immediate, you're stretching these things out potentially pretty far. And you can close over something. And if you're lucky, you're going to close over something like a result set, where when you go to commit the log, the thing is out of scope and closed down, and it'll just break. And then you'll know right away. But the worst case scenario is you close over something. You were in some for each or something, iterating over, and you close over data structures you weren't really expecting to. And your conditional logging ends up changing the memory allocation. So things that were expected to be wound within a single for loop or a tight call stack end up going all the way up to the top to the call site. And that can cause those issues. We've been trained to do this with debug logging. So it's something that basically if you combine that with log less, maybe you can just say, I don't need to do this. I'm not creating enough log entries where I need to do this deferred string construction. I can just construct them all the time and not really worry about it. But it's something that it's kind of implementation dependent. It depends on all your circumstances. So that does come up a fair amount. Conditional logging is, of course, the next one. Log levels, they always, well, what if I only want to do this in debug scenarios? The first thing to note here is, again, if we're logging less, we don't really care. But more importantly, I think, conditional logging, you can change your perspective. Like, what if you could say, now that I've finished executing this and I'm about to return the result to the caller, if it failed, I want the complete log. And if it succeeded, and it was fast, it succeeded in less than 20 milliseconds, I don't need to see any log entries there. And if it succeeded and it took in this time range, then I want to warn. And if it succeeded and took in this bigger time range, then I want to debug. Well, you can do that. That's exactly what we're talking about, is you accumulate the log through execution, and then you choose to commit it or not commit it at the call site when you're all done. And so you can do conditional logging on parameters that you didn't have access to before. That's one of the more powerful elements of this. The other thing is that if you do choose to do conditional logging down at the statement level, I recommend that people actually pass a log level to the method. So right now, there's this implicit dependency on that log configuration file. If you make it, and you can use Scala implicits, but if it's part of the type signature of the method, it indicates things to the caller. It's the exact same logic why you would return a try instead of just throwing exceptions. You want to indicate to people, hey, there's something going on here you need to be aware of. So one thing that some people end up is that they have log problems, right? When you have an immediate log, you can use the log to diagnose deadlock issues. And it's pretty simple, right? It's like the process is hung, show me the current log, the last couple entries in there, that tells me what I need to go and look at. And because we've lost immediacy, we're going to lose that facility completely. So there's two recommendations there. The first is that you can actually, if your log statements are timing their interiors, right? So the log function itself is a higher order function. It executes the thing that it's passed, so you can time the allocation. You could then implement deadlock detection pretty simply. You can store something off in a static. You can have a timer job that monitors things and say, hey, by the way, you be deadlocked and this thing has been executing for 90 seconds and I can tell you everything I know about it. So you can do stuff like that. Again, my solutions are based on simplicity rather than complexity, so I don't like that very much. What I would say is just stop using logging for that. Instead, let's just use tools that are better suited to look at a hung process and tell you what the call stacks are, app dynamics and a variety of others. So just 1 second. That's everything I have. We have time for one question since Daniel got in first. We'll give it a quick shot, and then I'll stay afterwards during the lunch break for people that would like to ask anything. Yes. Daniel's just asked a question which is too complicated to answer for the time we have allocated, but we'll definitely talk about it. But I know we're right up on we're a little past the intended lunch start. So thank you, and thank you for